So, today, 7.1 is ratios and proportions. You should have seen a little bit of this last year. You maybe just didn't go as in depth with it. A ratio at the top is defined as the comparison of two quantities. A ratio is just the comparison of two quantities. If I wanted to compare the number of girls to boys in our room, we have 19 girls and 8 boys in here right now. So I would have a ratio of 19 to 8. 4 different ways you could write a ratio. You can use the word to. So 19 girls to 8 boys. Might be weird just representing numbers here. You can write it with a colon. So I could say the ratio is 19 to 8. That should look familiar, right? Because some of you that are in bio, that's how you're writing your ratios.
Yeah.
Okay. You can write it with a division symbol. 19 to 8, you would still use the word to there. You hardly ever see it that way. That's just one way you can write it though. And then the last way, as a fraction. Ratio of girls to boys is 19 to 8. You will see the fraction most often in the math classroom. Since you're going to be writing your ratios for the most part as fractions, then we're going to have to make sure they are in simplest form. So you're always going to have to reduce your ratios, since we're going to write most of them in a fraction. Even if you write them with a colon, they still need to be simplified. Ratios always have to be simplified. So our first 2 examples are just going to be practice writing ratios. Number 1. A scale model of a car is 4 inches long. The actual car is 15 feet long. What is the ratio of the length of the model to the length of the car? Okay, when you see the word ratio, think fraction. I'm going to write a fraction. And then you have to read carefully. The length of the model to the length of the real car. When you write your ratios, you have to follow the order of which they're saying. Okay, so I'm going to write a fraction with the model in the numerator and the length of the real car in the denominator. So what was the length of our model?
4 inches.
4 inches, great. 2, that word 2 there, that's your fraction bar. The length of the real car?
15 feet.
15 feet, good. Ratios must always be written in simplest form. 4 over 15, can't reduce that, right? Nope. But when you're writing a ratio and you're comparing the length of segments, you have to put them in the same unit of measure before you reduce. So I need to convert these to either feet or to inches. Usually it's easier to go to the smaller unit. What's smaller, a foot or an inch? Inch. So I'm going to convert my feet to inches. So 15 times 12. 12 inches in 1 foot. So then this becomes 4 over 180. Once they're in the same unit of measure, then you look to simplify.
2 over 90.
Then break down to 2 over 90, Remy.
Oh, and then 1 over 45.
And then 1 over 45, good. I can't do any more. 1 over 45 is the simplest I can write that fraction. So my ratio is saying that for every 1 inch on the model car, that would be 45 inches on the real car. So if I have a little car that has like 1 inch stripes across it, on my real car, those stripes would be 45 inches wide then. Okay, so 1 to 45. You don't have to worry about putting the label on the final answer there. After you get it into the same unit of measure, you can drop that label. I'm not too particular with the label there. Questions on your first one? Cool. Number 2. A photo that is 8 inches wide and 5 1/3 inches high is enlarged to a poster that's 2 feet wide and 1 1/3 foot feet high. What is the ratio of the height of the photo to the height of the poster? Okay, so what is the ratio? Think fraction. I'm going to write a fraction. And then you have to read carefully what they're asking here for. The height of the photo to the height of the poster. So which of the four numbers should we put in the numerator of our ratio?
5 and 1/3.
Good. My numerator is going to be 5 1/3 because that's the height of the photo. 5 1/3 inches to, that's the fraction bar. The height of the poster. 1 1/3, Thomas, is that what you said?
Yeah.
Good. 1 1/3 feet. Okay. You have to look to reduce. So when you're looking at units of measure, they have to be in the same unit. Am I in the same unit yet?
No.
I gotta convert my feet to inches. So I'm gonna take this times 12. If I have 1 foot, how many inches is that? 12 inches. And then I have a third of a foot. So what's a third of 12? 4 inches. So it's really like saying 12 plus 4. So that would give me how many inches on there? 16 inches. 1 1/3 times 12 would be 16. Okay, that mixed number on the top. I don't really like mixed numbers. So let's turn it into an improper fraction. So when your numerator is bigger, take your denominator times the whole number, so 3 times 5. Add your numerator. So 5 1/3 is the same as 16/3. They're both in inches now. I have 16/3, a fraction, divided by 16. Instead of dividing fractions, what can we do?
Reduce. Or, get rid of.
Same change flip, what's that called? Good, multiply by the reciprocal. Instead of dividing this 16/3 by 16, let's multiply by the reciprocal. So, Janessa said same change flip.
I forgot the E on.
This stays, I know, and I forgot the A too. This stays the same, 16/3. Change your sign, because we're multiplying, by the reciprocal. What's the reciprocal of 16? 1/16. So we're taking 16/3 times 1/16. When you're multiplying fractions, you go straight across, like 1 times 16, 3 times 16. But you can also look to reduce first. The 16s will cancel out, because one's on the top and one's on the bottom. So when I multiply across, what do we get? 1/3. So the ratio of the height of the photo to the height of the poster is 1 to 3. Meaning for every 1 inch on the picture, that's 3 inches on the poster. Yay, fractions. Turn them into improper fractions, and then remember multiplying by the reciprocal. You can simplify first. If we wouldn't have simplified, this would have been 16 over 48, reduced by 16, and then you still get 1/3. Okay. Simplifying first just makes your math easier. Questions on your first two? Alright, you just have to read carefully on those types of questions. 3 vocab terms here. A proportion is 2 ratios set equal to each other. A proportion is defined by 2 ratios set equal. And I have 2 examples of proportions there underneath of that. A over B equals C over D when I write them as fractions. Read as usually, A is to B as C is to D. That's a lot of times how you'll hear it. When I have them written with colons, then you can see A is to B as C is to D. Proportion. 2 ratios set equal. An extended proportion, 3 or more ratios that are equal to each other. So a proportion is just 2 fractions that are equal. An extended proportion is 3 or more. This kind of comes into effect when we're comparing sides of triangles. There's 3 sides to a triangle. Or like quadrilateral or we're using extended proportions to compare them. When you solve a proportion, you use the cross product property. And it's stated the product of the extremes equals the product of the means. Cross product property states that the product of the extremes equals the product of the means. Mm-hmm. Extremes and means are referring to parts of the proportion. So if I go up to this first example here of my proportion, my extremes will be the outside two terms. So when I have it written as with colons, what are my two outside terms? A and D. They're on the outside. So those would be my extremes. My means will be in the middle. So up here with the colon, my means are B and C, because those two terms are right in the middle. But most of the time when we use our cross product property, we're doing it when they're set up as fractions. Extreme still means the ones on the outside. So when I read this first proportion, A is to B as C is to D, A was the first thing I said, D was the last thing I said, so they're on the outside. I said B and C in the middle, so those would be my means. So your means are in the middle, your extremes are on the outside. The cross product property says if you multiply the extremes, A times D, then that should equal the means, B times C. You used this last year. You may not recognize it right now, but once we get going, you'll see that it's familiar. Multiply the extremes, set it equal to the means. Questions on those terms? Cool, once you have it all filled out, go ahead and flip it over. At the top there, we have properties of proportions. Proportions can be written multiple ways and still get you the same answer or still mean the same thing. So on questions like this, you're just looking for the pattern. Proportions a lot of times are just patterns. So given my original proportion, A is to B as C is to D, then I'm able to say that A times D would equal what? C to B. You're finding what they did in the original one. They took A times D, and then you're just mimicking that pattern. So C times B. Or B times C, you could write it either way. So from the original one, A is to B as C is to D. Now they're saying B is to A as D is to C. So then this blank should be D over C. Third one. A is to C as B is to D. And then our fourth pattern there, A plus B over B equals C plus D over B. You'll have questions that'll there'll be multiple choice and it'll say which one is not the equivalent form. To check that, you use your cross product property. When I cross multiply my original one, I would get AD equals BC. Well, isn't that what number one says? AD equals BC. When I cross multiply number two, I'd say BC equals AD. Does that match the original one? I mean, minus the fact that they're on opposite sides of the equal sign, but still the same thing. When I cross multiply number three, I get AD equals BC. I know then that 1, 2, and 3 are the same as the original one because it's the same cross product way. Okay, so that's one way you can check that on your multiple choice questions. Cross multiply, if this one doesn't match the original one, then it's not an equivalent form. Most of the time when we're setting up the proportions, come tomorrow instead of today, there'll be like 4 different ways to set up the same proportion and get the right answer. So that's why they're trying to show you that it's okay if you have a different way to set it up. Larry.
Number 4, how do those ones say?
How would I do that one?
Yeah, the AD.
DA, wait, hang on. Oops. This would be D times A plus B, right? Equals B times C plus D. Okay, you ready? Distribute AD plus BD, right? Equals BC plus BD. Okay, if I take this BD and I move it over to the other side, I would subtract it over. What's going to happen to them? They would cancel out, and then when I get AD equals BC. Neat, huh? That's the first time I've ever checked that, Larry, in my entire life. Thanks for asking. Okay. Alright, number 3. It's one more like that. It says if A is to 4 as 12 is to B, then B is to 12 as 4 is to A. You kind of see what I'm saying when I say it's just a pattern? You're trying to figure out what they did to get there. Okay. You'll have a handful of questions like this today. The other handful, we'll be using your cross product property, which is what we're going to do here pretty much till the end. When you have a proportion, to solve it, you use your cross product property. So you multiply the extremes, which are the first and the last terms, so 2 times 35, and you set that equal to the product of the means, 5 times n. And it makes a nice line then, better equation you can solve. 2 times 35, divide both sides by 5. I got n equal 14. You can check these are algebra type questions. If I put 14 back in here, I get 2 over 5 equals 14 over 35. Can't reduce 2 over 5 anymore. But what can I reduce 14 over 35 with? 7. How many times would 7 go into 14? 2 and into 35. So wouldn't those be equivalent fractions? Sweet. Alright. Part B on number 4. Cross multiply the extremes, that's the first and the last. So 2 times the quantity x plus 1 equals the product of the means, 3 times x. You have to be careful here, because what do I have to do with my 2 out front? Distribute 2x plus 2 equals 3x. Subtract 2x over. And it tells us that x equals 2. Check these answers. If I put that back in, 2 plus 1 is 3, so that first fraction is 3 over 3. If I substitute 2 in on the right side, I get 2 over 2. Is 3 over 3 the same as 2 over 2? Sure it is, because they would both reduce to what? 1. So we're saying 1 is equal to 1. Okay, try the third one there, see. You have to be careful when you have to distribute. Some of you will try and do it in your head, and you'll forget to distribute to the second term. N would equal 6 times the quantity n plus 6. Distribute that 6 through, and you get 6n plus 36. Subtract 6n over to the left. 12n equals 36. Divide by 12, and we should get n to be 3. Plug it in quick. What's 3 plus 6? So that's 18 over 9 equals 6 over 3. When I reduce those, would that be the same thing? Yeah, I'd get 2 and 2. Alright. Next 3, extended proportions. So instead of 2 fractions, I have 3 fractions. You solve it using the cross product property still. But the cross product property says you only cross multiply two fractions at a time. So you're not gonna like zigzag multiply. You just pick two ratios at a time and multiply them. So do you want to multiply the first two, the last two, or the first and the last? The first two, because they have just an x in them. So you ignore the last ratio for a second, that 2x over y, and just use the first two and cross multiply. So 9 times x equals 3 times the quantity x plus 5. What? Zigzag doesn't work. Distribute the 3 in, and you get 9x equals 3x plus 15. Subtract 3x to the left. 6x equals 15. Divide both sides by 6, reduce by 3. 5 halves? Or 2.5 if you want to. I like fractions though. Okay, so once I have one value, I'm going to put that back into the proportion so I can find my other one. 5 over 2 all over 3, that's their first ratio, equals 5 over 2 plus 5 all over 9 equals 2 times 5 halves all over y. I know I have to use the last one because I have to solve for y. Do you want to cross multiply that with the middle guy or the far left guy? It's your choice. It's not going to matter. Far left, that's what I would went with too. So I'm just going to erase this for now. Cross multiply my extremes. 5 halves times y would just be 5 halves y, right? Equals, let's clean this up first. 2 times 5 halves is 5. This is actually just 5. So now I'm going to take 5 times 3, which gives me 15. Instead of dividing by 5 halves, what can we do? Multiply by its reciprocal. 2/5. They're going to cancel on the left side. The 2's cancel, the 5's cancel, so I'm just left with y. Remember when you do whole number to fraction, it's whole number to numerator. So 15 times 2 divided by 5. 6. So x is 5 halves or 2.5 if it's a nice decimal, and y is 6. Go ahead and try B. You have an extended proportion, you just pick two ratios at a time. Hey Lucas, what's it called when you multiply something times itself?
Square root. Or,
You
you square it.
square it, so like, instead of saying 2 times 2, I could just say 2 squared, right?
Yeah.
Okay. Or instead of like 12 times 12, I could just say 12 squared?
Yeah.
I can? Okay.
It's 1.
It's 144. So if I wanted to multiply y times y, I could just say y squared. Okay. To start this one, which two ratios should I multiply together? The last two, because they both have y's in it. Good. So we're cross multiply. 3 times 27 is 81. Lucas, y times y is y squared. Good. Not 2y, y squared. How do I undo a square? Square root. So we're going to take the square root of both sides here. Square root of 81. 9. Square root of y squared is y. I did mention the other day that when you take the square root of something, there's actually a positive and a negative value. we're always gonna assume they're positive unless otherwise noted. So you don't need to worry about negative 9 here, just the positive 9 value. Okay? After you get 9, plug it back into your extended proportion to find x. So we get x over 7 equals 3 over 9 equals 9 over 27. And then pick two of those ratios to multiply together. Obviously it has to be the first one. You want to go with the first and second or first and third? First and third?
First and second.
First and second? I don't care, it doesn't matter. Okay. First and second, 9 times x is 9x. 7 times 3 is 21. Divide by 9. Reduce by 3. 7 thirds. Or you could say 2 and 1/3. Yeah. Dos más. 2 more.
And one number 6.
We're on number 5, part C, right? X over 9 equals y plus 3 over 3 equals 8 over y minus 2.
Last two.
The last two. Good. We're going to start with the last two to solve for y first. So we're going to take y plus 3 times the quantity y minus 2 and set that equal to what?
24.
24. Good.
Y squared plus y minus 6
Good. I need to FOIL on the left side. Distribute twice. I have to distribute the y and the 3. We have to FOIL here. So if I distribute my y to both terms, y times y is y times negative 2. Inside terms, I'm distributing 3 now. 3 times y is, and then my last term's 3 times negative 2. Okay. Y squared. Is that going to cancel out at all? Okay. So what we want to do is bring everything on that side and set my equation to 0. So my y squared is going to stay on the left side because it doesn't cancel out. Combine your y's. Negative 2y plus 3y is y. And then I'm going to bring 24 over there so that my equation is equal to 0. So negative 6 minus 24 would give me negative 30. Quadratic equation. 2 ways last week. You can either solve this by factoring or using your quadratic formula. It's your choice. Remember, the quadratic formula always works as long as you memorize it correctly. Factoring doesn't always work, but if you can look at this and see that it might be factorable, then I would choose factoring. Where do you want to go with? I would choose factoring on this. They're not very big numbers. Is there a GCF? No. So I don't have to worry about taking anything out. My signs, because 30 is negative, will be the same or different? Different, so I'm going to hold off putting those in there. What times what will give me that y squared? Y and y. And then I need factors of 30 that are going to add and subtract to give me 1, right? So that's what's in front of my middle. 6 and 5, 5 and 6. I need it to be a positive 1. So should the 5 be positive or the 6? 6. We want to do negative 5 plus 6 to make that a positive 1. Okay, we're solving. That means you have to give me the actual answers. So what you do is take what's on the inside, y minus 5, and set them both equal to 0, y plus 6. Add 5 over, y equals 5. Subtract 6 over, and y equals negative 6. So I have 2 different y answers, which means we're going to get 2 different x answers. We have to plug both y's back in to figure out which 2 x answers we're going to get. If I plug 5 in, I'm just going to focus on the first 2. X over 9 equals 5 plus 3 over 3. 5 plus 3 in this numerator would give me an 8, right? So cross multiply. 3 times x is 3x. 9 times 8 is 72. Divide 72 by 3 and we get 4, okay. That's 27. And then plug negative 6 in and figure out what the x value would be there. So I'm still going to use those first two ratios. X equals 9, or x over 9 equals negative 6 plus 3 over 3 then. In my numerator, negative 6 plus 3 would become negative 3, right? What? Divided both sides by 3. Cross multiply here and I get 3x equals negative 27. Divide both sides by 3 and x would have to be negative 9. So when y is 5, x is 24. When x is negative 9, y is negative 6. You can check these like with quick self-checks too. Like when I put 5 in here, how'd you go from 3 to 9? Took your times 3, right? So if the numerator is 8, I should have to do the same thing. What's 8 times 3? 24 is not what we got down here? Yeah. And over here, 3 times what is 9? 3. So negative 3 times 3 should give me negative 9. Whatever happens to the denominator should also be happening to the numerator. So there's another quick self-check if you want to make sure you're doing them right. Good on proportions? Okay, last one. Story problem with a proportion here. A map uses the scale 1 centimeter equals 20 miles. So that means on the old paper maps, if you measured the distance between two cities and it measured 1 centimeter, then that would be 20 miles in real life. That's what they're telling us. Well, we have a county that's 90 miles wide, and we want to know how wide it is on the map. Okay, a lot of you can probably do this in your head. I'm not disagreeing with you. But you won't always be able to do it in your head. And questions like this will be worth 2 points. 1 for the proportion you set up, and 1 for the answer. A proportion, 2 ratios set equal to each other. My first ratio is this scale right here. 1 centimeter to 20 miles. Equals, then I gotta fill in the other side.
X over 90.
Good, they're telling me the county is 90 miles. So when you compare ratios, you have to compare like parts. So I need the 90 in the denominator so that I got miles and miles. And we're trying to figure out how many centimeters it is. With proportions, you guys, you don't have to have all of the same unit. You don't need to worry about converting these all to centimeters. You just have to make sure you compare centimeters in the same spot. So both in the numerators, my miles are both in the denominators. Cross multiply this. 90 times 1 would give me 90. 20 times x is 20x. Divide both sides by 20. And then you should get 4.5 centimeters then. Like I said, I know some of these you can do in your head, but show me the proportion because you won't always be able to do it in your head. Questions on these? Okay, Wilford?
So if I just show like the proportion in black,
That's okay. I would give you that. Hannah?
do you always have 2 answers for the one factors?
Because if you have to factor them or use your quadratic formula, then yes, you'll always have 2 answers. Good question. Alright, book assignment today. I forgot to put 21 in there when I typed it. So 2 through 20 even, 21, 25 through 33, and then 35 through 46. Those will be due tomorrow. And we'll have another book assignment tomorrow.